As we move into section 4.7 called the inverse trigonometric functions, I have the graphs of the six basic trig functions drawn on the board, but just to save time, you should pause the video and sketch the graphs of sine, cosine, tangent, secant, cosecant, cotangent, but with these restrictions. For sine, tangent, and cosecant graphs, sketch on the x-axis from minus pi to pi. So that's sine, tangent, and cosecant. Sketch the graph from minus pi to pi. For the other three, for cosine, cotangent, and secant, sketch the graph from minus pi over 2 to 3 pi over 2. Okay, let me say that one more time. So for sine, tangent, cosecant, sketch the graphs from negative pi to pi on the x-axis. And for cosine, cotangent, and secant, sketch the graph from minus pi over 2 to 3 pi over 2. So do those 6 graphs in the space that I gave you in the notes, and then when you turn it back on, we'll continue. Okay, so what we want to do here is define an inverse function for each of the 6 trigonometric functions. Now remember a while back when we did the, trying to find inverse functions, for example, y equals x cubed, the inverse function was cube root of x because they undid each other under composition. Okay, so that's what we want to try to do here. Now what's the issue, sort of trying to review what we talked about before. If we look at the sine graph here, notice sine of pi is 0, so when x is 0, when x is pi, the y value is 0. When x is 0, the y value is 0. And when x is negative pi, the y value is 0, right? So when we take sine of an angle and it gives us the number, right? To do an inverse function, sine inverse of the number would give me the angle, but what's the problem? To do sine inverse of 0, for it to make sense, it'd have to go to all 3 of those numbers, which it wouldn't be a function. Okay? Now you see what's happening with all 6 of the basic trig functions here. None of these functions pass a horizontal line test on their entire domain. Right? You draw a horizontal line, well, for example, on the x-axis, draw a horizontal line. Notice I hit it all 3 of those places, and that's why it's a problem. Same for cosine, tangent, secant, cosecant, cotangent. None of these graphs pass a horizontal line test. And keep in mind, the graphs go on forever in both directions. They're periodic. The pattern continues. So what are we going to do to create an inverse function? Okay, so if a function, the graph of a function doesn't pass a horizontal line test, there is no inverse function. Well, what's the issue here? For example, I picked these 3 x values and we had a problem. So let's make it so where we don't have all those x values. So what we're going to do for sine is only consider the part of the graph from x is minus pi over 2 to pi over 2. So I'm drawing that in black here. Now, I hope you agree what I've drawn here, just this black piece, will pass a horizontal line test. Right? So what we're doing is we're restricting the domain of sine. I'll just erase it. We're only going to go from negative pi over 2 to pi over 2. Okay? So this is the graph we're considering here. Now notice, remember the domain of sine was all real numbers, and the range of sine was negative 1 to 1. Notice I've included part of the graph that includes every value in the range from negative 1 to 1. Okay? Because when we take sine of an angle as a number, we want to be able to take sine inverse of every number in the range. So we want to have every number in the range. So what we're going to do is restrict the sine function from minus pi over 2 to pi over 2. So then when we do sine inverse, sine of an angle is a number. When we do sine inverse of the number, it'll give me an angle. But notice what we've done. We're only going to give angles from minus pi over 2 to pi over 2. Right? So if you do that same thing I did before, remember I had pi going to 0, 0 going to 0, minus pi going to 0. Notice now it's just 0 going to sine of 0, 0, so to go backwards, I'll take, just undo that, okay? So the only thing new here, the idea of inverse function we've talked about before, the new thing is, what's the restriction, right? So for sine, we're going to think of the sine graph as going from minus pi over 2 to pi over 2. Now what about cosine? I can't use minus pi over 2 to pi over 2 because that piece still wouldn't pass a horizontal line test, right? It'd go through the hill on both of these places. So for cosine, we have to pick a different restriction. Now again, same with sine, we still want to pick a restriction on the domain that gives us every value in the range. The range of cosine is negative 1 to 1. So what we do there is we go from 0, x equals 0, to x equals pi. Okay. Notice this piece in black will pass the horizontal line test, And every value in the range of cosine is taken care of, everything from -1 to 1. Okay, so let me erase that. So that's the graph we're looking at to do an inverse function. Now tangent, same idea. Now the range of tangent is -infinity to infinity, so we need to pick a part of the graph that goes from -infinity to infinity, and a part that passes horizontal line test. Well, it would make sense. Just take from -pi/2 to pi/2, that'll give us all the range values. So get rid of these over here, and we're only going to be looking at this. And cosecant, the problem here is, yeah, I mean, if you horizontal line is going to pass through a cup, two places. So for cosecant, what we do is same thing as sine. We go -pi/2 to pi/2. So get rid of that and get rid of that. Notice now this will pass, again, everything outside of that I'm getting rid of too, okay? So all the cups out here are gone too. So this will pass the horizontal line test now. And notice what's the range of cosecant? 1 and bigger and -1 and smaller. I've got everything. And secant, again, so we want half of the up cup and half of the down cup. So we're going to take that half and that half. And then cotangent, just like tangent, we want all the values going up and all the values going down. It makes sense just to take one whole branch here. So that's what we take. Okay. Okay, so now I've altered the graph, so I've restricted the domain. This is no longer the graph of sine x, it's a graph of sine x from -pi/2 to pi/2, etc. Now each of these graphs will pass the horizontal line test, so now we can do an inverse. So for example, now what do we have? The domain of this graph is -pi/2 to pi/2. And the range of this graph is from -1 to 1. No problem. And remember we learned in the inverse section, for any function, if you have an inverse function, the domain and the ranges swap. So notice when we do sine inverse, and we write it this way, y is sine inverse x to the -1. Again, that does not mean reciprocal. Okay, we have a name for 1 over sine, that's called cosecant x, okay? So this is the inverse. Remember, f to the -1 meant inverse function. It didn't mean reciprocal. So remember, the domain and the ranges switch. So what are we going to do? We're going to take sine inverse of a number between -1 and 1, and it will spit out an angle from -pi/2 to pi/2. So that's what you have to remember, the restriction. Right? So when we take sine of an angle here, we get a number between -1 and 1. We're going to take sine inverse of a number between -1 and 1, and it'll spit out an angle. But it's not any angle, it's an angle here. Same thing with cosine, okay? The domain of the cosine function I'm using here is 0 to pi, and the range is -1 to 1. That's this picture. So when I do y is cosine inverse of x, cosine of an angle is a number. Cosine inverse of a number from -1 to 1 is going to spit out an angle from 0 to pi. So notice these are different. Okay, these are different. Let me do one more like this and then we'll move on. Right? So the domain of tangent here is -pi/2 to pi/2. Notice not including pi/2 and -pi/2. And what's the range? -infinity to infinity. So that's for the tangent graph. So when I do tangent inverse, I'm going to take tangent inverse of a number, any number, and it's going to spit out an angle from -pi/2 to pi/2. Okay? Let me just do the same thing here. I'm really interested in the domain. So the domain here is -pi/2 to 0, but not including 0, union 0 pi/2. And notice here it's 0 to pi/2, not including pi/2, and then pi/2 to pi, including pi. And then for cotan, it's 0 to pi, including neither one. Now, the good news is, you don't have to memorize all the variations here. You don't think about the graph. I mean, they're all weird. Right? So when you take cosecant of an angle, you're taking cosecant of one of these, and it spits out a number. When you take cosecant inverse of a number, you get an angle here. And notice, again, they're all different, but you don't have to memorize that. Okay? So the key thing here to remember is 3 of them are similar and the other 3 are similar. Okay? So here's how I remember. if you look at, so this is at the very bottom of the page where I say pictures. Notice sine inverse, when you do sine inverse, you're going to take sine inverse of a number, and it's going to spit out an angle from minus pi over 2 to pi over 2. And notice, I'm going to say first and fourth quadrant, but when I say fourth quadrant, it's not all the way around this way. It's 0 up to pi and 0 down to minus pi. So there's sine inverse. So when you take sine inverse of a number, you get an angle here from minus pi over 2 to pi over 2. Now what about tan inverse? You're going to take tan inverse of a number, and it's going to spit out a number from minus pi over 2 to pi over 2. Notice the endpoints aren't included, but this picture will help you remember. Right? So sine inverse and tan inverse give angles from 0 to pi and 0 to minus pi, but tan inverse you can't have the endpoints. Now what's another one like that? Notice cosecant is going to have the same thing. When you take cosecant inverse of a number, you're going to get an angle from here to here. Now notice the pi over 2's are included, but not the 0. But it has the same flavor. So when you take cosecant inverse of a number, you're going to get an angle here, 0 to pi, 0 to minus pi, but not including 0. The good news is you don't have to remember the restrictions. The reason is because if you take cosecant of 0, you get undefined, right? Cosecant of 0 is undefined. So that means cosecant inverse of undefined would be 0, but that doesn't make any sense. Okay, so 0 is a problem here, but you're never going to take cosecant inverse of undefined to get the 0, so you don't really have to memorize the 0 is a problem. Same thing with the tan inverse, right? Tan of pi over 2 is undefined. That means tan inverse of undefined should be pi over 2, but that doesn't make any sense. Right? So you can't get pi over 2 when you do tan inverse, so it doesn't matter if you remember the endpoints or not. You can't get them. Okay? So if you can just remember this picture, sine inverse, tan inverse, cosecant inverse. When you take sine inverse, tan inverse, or cosecant inverse of a number, it'll spit out an angle from minus pi over 2 to pi over 2. First and fourth quadrants. Okay? And again, all the special exceptions you don't have to memorize, because you can't get 0. When you take cosecant inverse of a number, you can't get 0 as an answer. It's impossible. Okay? Now what about the other three? Notice cosine inverse will be running from 0 to pi, here to here. Notice cotan inverse is going to run from 0 to pi, not including the endpoints, but again, you don't have to memorize that because you can't get the endpoints anyway. And notice secant inverse is going to go from 0 to pi, not including pi over 2. But it's still this picture. So cosine inverse, cotangent inverse, and secant inverse. So if you can remember these three are minus pi over 2 to pi over 2, the other three inverse trig functions go from 0 to pi. That's the new thing. That's all that's explained in the bottom down there with the domain and the range. Okay? So this is the new thing. And this is based upon the restrictions we chose up there. So sine inverse of a number is an angle, and the angle's here. Cotan inverse of a number, the angle is here. Okay? Notice there's never an answer in the third quadrant. You're never going to get sine inverse of a number is an angle, and the angle's in the third quadrant. Or cosine inverse of a number is an angle, and the angle's in the third quadrant. It's not going to happen. Okay, so with that in mind, we can now work some problems. Again, that's the new thing here, is the restriction. We had to restrict the domains of all 6 trig functions in order to create an inverse trig function. And so the new thing is just remembering the restrictions. Okay, and here they are. Okay, let's do a problem. Oh, I didn't mention, right? Another notation for inverse sine is arcsine, arctan, etc. Okay, so I'm using them interchangeably. Make sure you realize sine inverse and arcsine are the same thing. Okay, so the first example says, find each exactly in radians. Okay, exactly means don't use the calculator. And it says sine inverse of 1 over square root of 2. Okay, now, I always try to get my bearings straight on these problems. What do I have? What am I looking for? Right? So I always think of it this way. You take sine of an angle, and it spits out a number. That's what we've been doing. Therefore, sine inverse of the number spits out an angle. Now, in radian measure, for those of you who may have seen trig before, in radian measure, you can think of the angle as being a number as well. But I'm just thinking, sine of an angle is a number, sine inverse of a number is an angle. So I'm taking sine inverse of something here. What is this something? You take sine inverse of a number, and the answer here is an angle. Well, let me call that angle something. I'll just call it theta. Sine inverse of a number is an angle, okay? So whenever I have an inverse trig function problem like this, I write down two facts. Once you get the two facts, we're back to where we were before with drawing pictures, okay? Sine inverse of a number is an angle. That means sine of the angle is the number. No problem, right? I'm just using this fact here. We talked about, we've already known about this, right? Even though we haven't talked about sine inverse, it makes sense, right? Sine of an angle is a number. The domain and the range switch for inverse functions. So sine inverse of a number is an angle. And based upon this, if you take sine inverse of a number, where's the angle? The angle is here or here, right? It's either in the first or the fourth. But we know sine is positive. Notice the way we've chosen these, each one of these is positive in one and negative in the other. Sine is negative in the fourth and positive in the first. If sine is positive and we only have first and fourth to choose from, that means theta has to be in the first quadrant. There's my two facts. Right? That's what I'm getting from this. So sine inverse of a number is an angle, sine of the angle is a number. Because of this, right, sine of the angle is a number, when you take sine inverse of a number, you're in the first or the fourth quadrant, but sine is negative in the fourth, so theta must be in the first. Okay, so with that in mind, we can draw a picture, right? We've been doing this. So theta's in the first quadrant, and normally I say I just draw in a rotation because it bothers me to leave it out. I actually know the rotation, right? For these inverse trig functions, sine is going up or down. So I'm going up in the first quadrant. So here's theta. I actually know that's what theta looks like. And sine is 1 over root 2. That's opposite over hypotenuse. And you should recognize right away those are two numbers in the special triangle, right? So I know the other side is 1. I'm in the first quadrant, so none of the numbers are negative. And it's just a matter of figuring out what's theta. Well, for the 1, 1 square to 2 triangle is your 45, 45, 90 degree triangle. But remember, it says give all the answers in radians. So what is theta here? 45 degrees is pi over 4, right? So once you change this to the two facts, draw a picture based upon your two facts, and you can figure out the reference angle. You can figure out theta. Okay, so that's the only new thing is this. That's what's new here. The idea of inverse functions, we already know. We're just applying it to the trig functions. And it's just writing the two facts, okay? Let's do another one. It says tan inverse of negative 1. Tan inverse of negative 1. Okay, so again, you take tan inverse of numbers, and it spits out an angle. I'll call it theta again. Okay? So let's write the two facts, right? Tan inverse of a number is an angle, so tan of the angle is the number, no problem. And now it's just a matter of figuring out where is theta. Well, when you take tan inverse of a number and it spits out an angle, you're either in the first or the fourth. Well, the tangent is negative, so theta can't be in the first, which means we're in the fourth. Theta is in quadrant. There's my two facts, right? So the first fact is easy to get, right? You're just undoing it with the regular trig function versus the inverse trig function. And tan is negative, or tan inverse of a number is an angle, means the angle's in first or fourth. Tan is negative, so theta's in the fourth, right? So with that in mind, we can draw a picture. Again, I know because we're doing tan inverse that it's not all the way around like normally I draw. It's a negative angle like this. Right? For tan inverse and sine inverse, you're either up in the first or down in the fourth. That's it. Tangent's negative 1. Think of that as minus 1 over 1. And again, remember, the negative could either be in the numerator or the denominator. I don't know which yet. But treat these as your two sides, right? Tan is opposite over adjacent, so opposite and adjacent are both 1s. And obviously from my picture, the negative has to go on that, because in the fourth quadrant, x is positive and y is negative. Again, it's the same special triangle we had before. The hypotenuse is square root of 2. And you know from what we just did that, oh, this is theta. That my angle theta here, the reference angle is 45 degrees again, isn't it? Because those two sides are the same. And so that's 45 degrees. The reference angle, So what's theta here? Again, it's a negative angle, so it's negative 45 degrees, which is pi over 4. Again, the question asks for the answers in radians. Okay, so again, once you get your two facts, you can draw the picture. And again, if they say do it exactly and without the calculator, it's either a special triangle or quadrantal. Those are the only ones we know how to do right now without the calculator. Okay? Oh, I should know. That's all. Okay, and then C says arc cosecant of minus 2 root 3 over 3. Okay? So we want to find what this is. Remember, arc cosecant means cosecant inverse. Cosecant inverse of a number is an angle. I'll call it theta. Let's write our two facts. So arc cosecant inverse of a number is an angle. So cosecant of the angle is the number. No problem. Okay. Now, the other part is, in which quadrant does theta have to be? Okay, think a minute and see if you can figure out what quadrant, in which quadrant the terminal side of theta would have to be. Okay, remember cosecant inverse, arc cosecant of a negative number, arc cosecant's either in the first or the fourth, but since cosecant is negative, theta has to be in the fourth. Okay, so let's draw a picture. I know I'm in the fourth. Again, I'm not going all the way around. You come down. So there's a picture of theta. Now, cosecant is what side over what side? Cosecant is hypotenuse over opposite. So the hypotenuse is 2 root 3. The opposite is 3. Cosecant over opposite. Right. And obviously the negative, so even though the negative is written with the 2, well, I wrote it, yeah, the negative's with the 2, it really is on the negative 3, and it's on the 3 in the denominator. Now, this may not be obvious to you what's going on here, but we could use Pythagorean theorem to find the other side if you're not sure what's going on. So I'll just call this side x. So x squared plus 3 negative, well, just ignore the negative, plus 3 squared is 2 root 3 squared. Whole thing squared. So this is x squared plus 9. Well, 2 root 3 times 2 root 3. Well, 2 times 2 would be 4, and then root 3 times root 3 is 3, so that's going to be a 12. Right? I'm doing 2 root 3 times 2 root 3. The 2 times the 2 is the 4. Root 3 times root 3 is 3, and 4 times 3 is 12. Okay, so when I subtract 9 from both sides, I got x squared is 3. And in the fourth quadrant, I mean, x is going to be positive, so x is square root of 3. Okay? Now, do you recognize what's going on here? It wasn't really obvious with the two numbers we started with, but perhaps it is now. I told you if they ask for a problem that says find the exact value, it's either quadrantal or special triangle. Now, which special triangle is this? It can't be the 45, 45, 90 because the two legs are not the same, right? So this has to be the 30, 60, 90. Right? Now, a way to recognize that, the easiest way, in my opinion here, is notice the hypotenuse is double this side. Okay, that's how you know it's the 30, 60, 90. And in particular, which is the shortest side? Well, the hypotenuse is double the short side, so your 30 degrees is down there. That's your 60 degrees. Or another way to see is, notice this side is square root of 3 times that side. Remember, the long leg is root 3 times the short leg in the 30, 60, 90. So the numbers here weren't obvious. It was in the special triangle. But once you figure out the other side, and you know they want exact value, so it has to be a special triangle. It's not the 45, 45, 90 triangle. My hypotenuse is double this side, so that's like your 2 and your 1 in your 30, 60, 90 triangle. And so there we go. And so to answer the question now, what is theta? Okay, again, we're going down in the fourth quadrant. It's a negative angle. It's negative 60 degrees, which is negative pi over 3. There's your answer. So again, once you get the two facts, you draw your picture, and then you just have to sort it out from stuff we already know. Okay, now D says arc cosine of negative 1. Okay? So you take arc cosine of a number, and that spits out an angle. Remember, arc cosine is cosine inverse. Arc cosine of a number is an angle. I'll call it theta. So let's do the two facts. So cosine of theta is negative 1, right? Cosine inverse of the numbers and angles, so cosine of the angle is a number. And then we have to figure out where is theta. Well, remember, our cosine gives you a number from 0 to pi. Cosine is positive in the first, so it looks like theta is in the second. Okay? So, cosine inverse of the numbers and angles, so cosine of the angle is a number. Cosine inverse, our cosine, gives you a number from 0 to pi. Cosine is positive in the first, so therefore theta is in the second. Now, I'm sort of leading you down the garden path here. I'm just trying to follow what I did before. So if you follow that, I'm actually going to draw two pictures here, so give yourself a room if you can. Right? So if I draw theta in the second quadrant, no problem, and I do know that's the correct rotation, and I think of this as 1 over 1, well, what's cosine? Cosine's adjacent over hypotenuse, and in the second quadrant, x would be negative. So based upon this information, this is the picture I've drawn. Now, what's the problem here? In a right triangle, the leg and the hypotenuse cannot have the same length. This picture makes no sense. Okay, so again, I just followed my intuition from what I did on the previous problems. Now, what's the issue here, right? I mean, this is definitely a problem, right? If I write negative 1 is negative 1 over 1, the adjacent side is negative 1, the hypotenuse is 1. What's the problem here, okay? So I'm doing this on purpose so you can see. When you draw a triangle picture that makes no sense, that tells you the triangle picture is the wrong picture. This makes no sense. What is going on this problem? If it's not a triangle picture, what is it? It's a quadrantal angle, okay? So it's the wrong picture. And you may not realize that until you get going, right? As soon as I put the 1 on the 1, you should realize that doesn't make any sense. So if this is the wrong picture. It's not undefined because your picture doesn't make any sense. What's the problem here? It's really a quadrantal. Now, so theta is not really in the second quadrant. Okay, that's why I said I'm leading you down the garden path. Theta is not in the second quadrant. It's a quadrantal angle. But because I said second quadrant here, I know it's either here or here. Okay, so that's actually a lie. Okay, it's not really in the second quadrant. It's on the boundary. So this is the point 0, 1. Pick the point 1 unit away. I'm using unit circle. There's minus 1, 0. Remember, the first number on the unit circle gives you the cosine. So cosine is 0 here and negative 1 here. We need the negative 1. And where's that angle? From here to here is pi. Okay, so I did this example on purpose, drawing the wrong picture, because this is going to happen to you. So once you have your two facts, try to draw the triangle picture. If that falls apart because it doesn't make sense, your angle you're looking for is a quadrantal angle. Use the unit circle. Okay, so that's basics here. Notice it's the same thing over and over and over again. Right? I write down the problem. I call it a theta if it's not already called theta. Write down the two facts and then draw the picture. The next one says use the calculator. Let me write these down. Y is sine inverse of 0.1234. Y is secant inverse of minus 1.41. And then the last one is y is cotan inverse of minus 4.2. Okay, it says use the calculator. Let me get my calculator. Okay. And it says, oh, just fine. It didn't say, okay. When you take sine inverse of a number, it's going to give you an angle. My point is it didn't say radians or degrees. I think it said at the beginning, yeah, all angle measures in the homework are given in radians. So it didn't say to use radians here, but so that's what we're going to use. Again, in calculus, everything is done in radians. So that's why they want all the answers in radians. Okay, so here, so make sure you are in radian mode, because we want the answers in radians. Mode matters when you take sine of something, cosine something, tan of something. Mode matters when you take sine inverse, cosine inverse of something, okay? That's when mode matters, when you have the trig function or the inverse trig function. Now again, sine inverse is not the same as cosecant, okay? So to get this, that's where you use second sine. So second sine, so sine inverse of 0.1234. I'm in radian mode, and this gives me, it doesn't say what to round, so 0.1237. 123.715. That's what I got. So again, to get the sign inverse, it's typically a second sign. So hit the second button and then sign, and then 0.1234. Okay, so sine inverse of the number. How do I know which one's the number, which one's the angle? You take sine inverse of a number and it spits out an angle. So this is the angle in radians, all right? So this is, you don't need the units, but, right, if you want to emphasize. So this is the number. Sine inverse of the number is the angle. Now, we have the same problem with secant. Secant inverse that we have with taking secant. There's no secant button on the calculator, so you can't do second secant to get this. Okay? So here's what you do on a problem like this. Right? Secant inverse of a number is an angle. So secant of the angle is the number. I'm just rewriting it in terms of the secant. Again, I have a problem because I still want a secant button, but what can we do? Let's change this to a cosine problem. Right? If secant of y is minus 1.41, what's cosine of y? Cosine is a reciprocal of that. Okay? So this is what you have to, just like when we had to use the calculator for secant of something, we said 1 over cosine. We change it to a cosine problem to use the calculator. Here I'm changing this to a cosine problem. Now cosine of an angle is a number, so the angle is cosine inverse of the number. There we go. And then that is something we can type in. Okay, again, I'm still in radian mode. Again, anytime you type anything in the calculator, check your mode. Cosine inverse of 1 over negative 1.41 is 2.359. And again, that's radians. You don't have to write it, but I'm just doing it for emphasis, right? Secant inverse of a number is an angle. The angle is 2.359 radians. Now, does this answer make sense, right? Remember, when you take secant inverse of a negative number, you're in the second quadrant, and where's a little more than 2 radians? In the second quadrant. The answer makes sense. Right? Same thing here. Sine inverse of a positive number, you're in the first quadrant. 0.1237 radians is in the first quadrant. Remember, 1 radian is about like that. That's a tenth of that. Okay, now what about this last one? Same idea. I don't have a cotan button, so I don't have a cotan inverse button. So let's rewrite it. Cotan inverse of the number is an angle, so cotan of the angle is the number. And then we're going to change it to a tangent problem. So tangent of y is 1 over negative 4.2. Right? So cotan inverse of a number is an angle. Cotan of the angle is the number. We don't have a cotan button, so change it to tan. Tan is the reciprocal of cotan. Right? So tan of an angle is a number, so the angle is tan inverse of the number. So I'm doing the exact same thing that I did over here. So if I type this in, again, I'm in radian mode. So tan inverse of 1 over negative 4.2, I'm getting that y here is minus 0.2337 radians. Okay, so hopefully you did too. Does this answer make sense? When you take cotan inverse of a negative number, where are you supposed to be? Right? The terminal side of that angle should be in which quadrant? Cotan inverse of a negative number puts you in the second quadrant. Where is this answer? Negative 0.2 radians is in the fourth quadrant. That can't be the right answer. What's the problem here? Okay. Now you have to do what we did. So leave your work. Don't erase your work. You have to get down to this point. But what I have here is a lie. That actually isn't y. Okay. Right. That can't be the answer for y. It's not the same thing, right? So tan inverse of that is that. Now what's the issue here? Think about what we've done. Cotan inverse of a negative number, y is supposed to be in the second quadrant. Right? We typed in tan inverse of this and got this answer, which can't be right. But the calculator did exactly what we told it to do. When you take tan inverse of a negative number, where is that supposed to be? Tan inverse of a negative number is in the fourth quadrant, and that's what the calculator gave us. The calculator gave us exactly what we typed in. Okay? Now, why didn't we have that problem? Why didn't we have this issue in the last problem? Because remember, the last problem was secant inverse of a negative number, secant inverse, And cosine inverse, that's what we changed it to, was a cosine inverse problem. Secant inverse of a negative number and cosine inverse of a negative number are both in the second quadrant. Likewise, if you do sine inverse of a negative number and cosecant inverse of a negative number, remember those are here and here, those are both in the fourth quadrant. Right? So if you take secant inverse of a negative number and change it to a cosine inverse problem, you'll get the right answer. If you take cosecant inverse of a negative number and you change it to a sine inverse problem, it'll give you the right number because both of those are in the fourth quadrant. What's the problem here? Right? We are interested in cotan inverse of a negative number, which should be here. We typed in tan inverse of a negative number, which is in the fourth. That's the problem. So the only time you're going to have this situation is here. Now notice, if we were doing cotan inverse of a positive number, cotan inverse of a positive number would make this positive, would make this positive, would make this positive. Tan inverse of a positive number is in the first. Cotan inverse of a positive number is in the first. So if that had been a positive number, we would have gotten the correct answer. So in all the combinations, the only time we run into this problem is cotan inverse of a negative number. That answer is supposed to be in the second, but when you do it this way, tan inverse of the negative is in the fourth. All right, so that's a long explanation to explain why this is a problem. Now, how do we fix it? All right, well, let's think about what this is just basically, memorization at this point. All right, so let me, you don't need the picture here, but let me explain the picture. So cotan of y is minus 4.2. If I think of that as over 1, right? So cotan inverse of a negative number, right, that we're in the second quadrant. Our answer y is supposed to be in the second quadrant. And cotan is the adjacent over the opposite. Right? So this is a picture of angle y. That's what we're supposed to be finding, this angle right here, right? Cotan y is negative 4.2. Think of that as over 1. I know y is in the second quadrant, so cotan inverse of a negative number is in the second. And cotangent is minus 4.2 over 1. So this is the angle I'm looking for. Now think about what we have here. Okay? So tan inverse of that, what I'm drawing here, what I asked the calculator to do here, right? If you say tan is negative and you're doing inverse trig, that would be it here in the fourth quadrant. Right? But tangent would be 1 over negative 4.2, so it's opposite over adjacent. Right? Now look at if you look at the reference angle here and the reference angle here, notice the opposite is 1 and the adjacent is 4.2. These two triangles are congruent. So the reference angle here and the reference angle here are the exact same thing. Okay? So the work that I did here, you still have to type this in to get this answer, but this is not y. But notice what this is. This is the angle right here. So the reference angle is 0.2337 radians. Okay? Which means the reference angle here is 0.2337 radians. So the angle we need for y, the original y, is just the supplement of 0.2337. Okay, so again, it's a long explanation, but I'm trying to explain where this is coming from. So you have to type this in to get that, to get the reference angle. What is the original answer now for y? Right? It's pi minus the reference angle. So whatever that is the actual true answer to the question. Pi minus 0.2337 is about 2.908 radians. And notice that answer makes sense, right? That is in the second quadrant, which is where our answer is supposed to be. Okay? Whew. So the only time this situation comes up is when you're taking cotan inverse of a negative number and you're using the calculator to get it like this. Okay? So again, now it would be very quick now that you understand what to do. Change it to a cotan problem, change it to a tan problem, take tan inverse of the number, that without the negative is the reference angle, so pi minus that is going to give you your answer. So now that you understand how to do it, it doesn't take that long. Okay, so for the last two problems here, it says write an algebraic expression, so I mean with x's in it, that's equivalent to the given expression, okay? So the first one says sine of arctan of x. Now we've done problems like this before We just didn't write it in terms of the inverse trig functions. Okay? So ignore the sign there for a second. Just ignore the sign. Right? Let's focus on arctan x for a second. Arctan x. Now what kind of thing is x? You take arctan of a number, okay? So x is a number, and that spits out an angle. I'm going to call the angle theta. Okay, so I'm ignoring the sign. I'm just focusing on the arctan x. Right? Arctan x is an angle, and no, what's the answer here, right? Arctan of, you always take arctan of a number. Arctan of a number is an angle. Sine of an angle is a number. So the answer at the end of this is going to be a number. But it's going to be expression with x. It's not going to be an actual number. Okay, so ignore the sign. Arctan of x, arctan of a number is an angle. All right, let's write our two, let's write our two facts, right? Arctan of an angle is arctan of a number is an angle. So tan of the angle is the number. Now we don't, the problem here is where is theta? Right? See, I don't know. If x is positive, I'm in the first quadrant. If x is negative, I'm in the fourth. So I don't really know, right? But let me draw a picture for both. Let's draw a picture. So if theta's in the first quadrant, it'll look like this. In the fourth quadrant, it'll look like that, right? But in both situations, tangent is x over 1. Right? If you just have a single number, just put it over 1. And tan is opposite over hypotenuse, opposite over hypotenuse. Okay? Now, I need this other side. Now, I've used x because I used x here. Notice it's really side y. I need to call this something else. I'll just call it q. So how can I figure out q? Notice in both of these pictures, q is just one of the legs of the triangle. So q squared plus x squared is 1 squared. Notice whether x is positive or negative, when I square, it goes away, so it doesn't matter. And so I want to solve for q. Q squared, that's 1, is 1 minus x squared. Notice whether I'm in the first or the fourth, q is going to be positive, right? And so I get q is the positive square root of 1 minus x squared. So notice whether I'm in the first or the fourth, this side is square root of 1 minus x squared. Q is positive because in the first it's q this, q that. So q is positive. Okay, so now in my picture, I didn't make my picture big enough. This side is the square root of 1 minus x squared, which is not the same as 1 minus x. You cannot take the square root of 1 and square root of x squared. It doesn't work that way. Well, I have my triangle picture now. Whether I'm in the first or the fourth, right? We just need sine of this angle, right? This is theta. I just need sine of theta. Now, what's sine? I put them in the wrong place. Sorry. That's the problem of video. Let me try this again. Sorry. Okay, erase those pictures. Goodness, you probably realize I made a mistake. Right? Tangent, right? So arctan, that's still true. That's over 1. Okay, let me draw the picture again. So if I'm in the first quadrant or the fourth, right? Tangent is opposite over adjacent, right? Opposite over adjacent. I found the wrong side. I put the 1 in the wrong place, sorry. Okay, now I need to find the hypotenuse. I'll call that q. Or let's call it what we did before, say r. So 1 squared plus x squared is r squared. Same thing here, right? That r and that r would be the same because both of that's 1 in x and that's 1 in x. So then that's 1, so r is the square root of 1 plus x squared. So that's the hypotenuse on both of those. Okay, now that I have the correct picture, let's take the sine. Sine is opposite over hypotenuse or opposite over hypotenuse. So it's just the opposite. It's x over the square root of 1 plus x. So we've done these before. Apparently I need more practice. Where this is the same thing as they give you one trig function and you find another. Right? It's the exact same problem. Right? They told us one trig function. They didn't write it that way, but this is this. Draw your picture, find the other side, and then take that. So sine didn't have anything to do with anything here. Once you have the picture, once you have the correct picture, you can just take the sine. And the last one's similar. It says cosecant of arc cosine of x minus 1. Okay. So again, the cosecant out front isn't the important part, right? So arc cosine of a number is an angle. Again, I'm ignoring the cosecant, focusing on the angle. that means cosine of the angle is the number. Think of this as x minus 1 over 1. Again, I don't know whether the arc cosine is, whether the x minus 1 is positive or negative. So let me just draw this in the first quadrant. I mean, we're either in the first or the second. And cosine, let me be careful here, is adjacent over hypotenuse. Adjacent over hypotenuse. So notice it doesn't matter which quadrant we're in. This side and this side are going to be the same. They're both positive. Okay? Just like over here. It didn't matter whether it was first or fourth. R was going to be positive. Okay? So we need to figure out that other side. So we'll use Pythagorean theorem again. So if I call that y on both of them, so x minus 1 squared plus y squared is 1 squared. Right? X minus 1 squared plus y squared is 1 squared. Same thing over there. So if I multiply this out, I get x squared minus 2x plus 1 plus y squared is 1. X squared minus 2x plus 1, yeah. Again, I'm trying to solve for y, so if I subtract all this from both sides, I get y squared is 2x minus x squared. Right, the 1's subtract out, subtract x squared from both sides, add 2x to both sides. And notice y is the square root of 2x minus x squared. So that's y for both of these pictures. So to go back to the original problem, what does this turn out to be, right? I want the cosecant of that angle. Cosecant is hypotenuse over opposite. So that's how you do those problems, and that's the end of the section.